Alright, so one problem I have with my printer on occasion is I'll be in the middle of printing a part like this, and this is about a 6-hour print. So what happens every once in a while, it'll be in the middle of printing a part, and I'll come down and check on it, and it's like it stopped extruding. And I'm left with something like this. Now this could happen for multiple reasons. It could run out of filament, but you know, I usually keep a pretty good eye on it. So usually, while I have a part printing, I'll go check on it every half an hour or every hour or 2 hours or whatever. So in the past, I don't know, 4 or 5 years I've been 3D printing, I've only ran out of filament twice. So usually this is because the extruder clogs or jams or whatever. Sometimes, you know, I could figure out what the problem is. Other times it just seems like it's completely random. And it's like every time it happened, I told myself, next time it happens, I'll buy a filament monitor. And finally, it happened enough times I bought a filament monitor. Now, there's a couple of different types of filament monitors. There is a really simple type that's basically just a switch. It only detects if there's filament there or not. So that's good if you run out of filament. But I wanted a monitor that would detect when the filament is actually moving. So I bought this one. This is a smart filament sensor from Bigtreetech. Came in a nice box like this. And it was cheap, as only 20 bucks. And the idea behind it is there's a rotary encoder, so it's actually sensing when the filament is moving, and when the filament stops, it would then pause the printer. Now, this was not designed for my printer. I know it's possible to make this work with my printer, but the more I'm thinking about it, the more it's like, more importantly for me, instead of pausing the printer, I want to know when it happens, so I could go down and rectify it, get the filament re-going, and just keep the part printing. Because if all it does is pause the print, and I don't come down to check on it for a couple of hours, well, that's a couple of hours wasted. Now, it'll save the material, but it'll still waste the time. So if I could connect this to an alarm so that when it stops moving, it would notify me right away, I could go down, rectify the problem, and then just keep the print going. And one thing about when I print parts, I almost never print a part and then leave the property. I'm always at home. I'm in the house somewhere, in the backyard, usually in the garage. So if I could just be notified about it, you know, if the extruder jams, as long as you catch it within the next couple of minutes, you could save the part. So I wanted this to let me know, no matter where I was in the house. Now, eventually later, I might do some more research to figure out how to make it pause the machine, so it'll pause it and let me know. But for now, I just want this to run an alarm. So let me show you how this works, what kind of signals we're working with here, and how I plan on connecting this to an alarm so it'll tell me when there's a problem. Okay, so I have this connected to a prototyping solderless breadboard, and basically just a couple of LEDs, a couple of resistors. This is just a little prototyping power supply I'm using for this, just for getting my my circuit functional. So you'll notice one LED is on. I don't know how bright that is in the video, but one LED is on, and you'll notice that on the unit, the connector, one of the wires has like little plus marks on it. That is positive. So that's the far wire, that way is positive. The next wire is your negative. And then the final wire, the third wire, is your signal. So every time this is moving, if you watch the LEDs here, so every time this is moving, the LEDs will alternate, just like that. I guess I could put a better LED in that one, just so you could see it better, but I think you get the idea. So when the filament stops, when the extruder jams, well, it could be there, or it could be there. So if I just move it a little bit there. So as long as there's a pulsing signal, everything is good. So I need to build a circuit that will detect when it stops pulsing. So basically what I want is when that light comes on, I have a circuit that starts counting, and it could be a variable time, and I'm probably thinking 15 to 20 seconds, maybe 15 seconds. And after 15 seconds, then it triggers an alarm to alert me that there's a problem. Or if it fails with that one on, I want it to start counting again. So what happens is, as soon as one comes on, well, the circuit's going to start counting. But as soon as it goes to the next one, then that circuit's going to restart. It's going to reset, and it starts counting again. So what I need is, I need a clocking signal to just give a signal every second or so. And I need another circuit that will count those seconds, but it has to reset every time that changes. Now, usually on counters like BCD or binary counters or something like that, there is a reset signal. Usually it resets like when that signal goes low, which would basically only work for one of those. So basically the output signal, as this is turning, the leg will go low, then it goes high, then it goes low, then it goes high. So if it failed on the high side, it wouldn't reset. So I would have a 50-50 chance of it not resetting. So what I need is, for every time one of those comes on, I need a low to high pulse, just a single low to high pulse. So as we said before, the signal from this, as this is moving, is putting a signal coming out there, which is this line right here. So we have power coming in first, then a ground. By the way, my power and ground are coming from this board. This is just the power supply I was using earlier. I could just put it on here, but I just, to keep it out of the way and other reasons. And I have a wall outlet adapter, puts 9 volts in here, gives me 5 volts out. So that's just out of the way there for now. So 5 volts in and ground, and then the signal coming out. So again, the signal is going into that first IC here is the DM74LS04 hex inverter gates, and I'm only going through 3 of them. So I'm taking a signal, running them through 3 in series. What that does is it gives me an opposite signal out, but it goes through a time delay. If I just would have gone through 1, then that time delay would have been like really, really, really short. But since I'm going through 3, it gives me a little bit of a longer time delay. And that signal is also going through, so that one signal I'm branching off into 2 places. Again, one goes through 3 of the hex inverters, and then gives me an output to this other IC. The same signal also branches off, bypasses the hex inverters, and then goes into that other IC as well. The other IC is the DM7486 quad 2-input exclusive OR gate. I'm only using one of those right here. So again, just to kind of show, let me get this out of the way for now. If we just lined these up like that and find a marker, this will work. That marker doesn't work. So here's the motion sensor. And again, every time that thing detects the output signal, goes here, and then here, and then here, and then finally out. And also, I tap off of that same signal. I'm going to bring it down this way, and that's going to come over to that gate here. The output here feeds into that gate here, and then this is the final output right there. All right, so let's say this goes high. So that's going to give me a 1 here, and right away a 1 here. And with that 1 here, that's going to give me a low. And then out of this one, a 1. And then out of this one, a 0 or a low. So now I have a 0 over here. So I have a 1 and a 0 with an exclusive OR. As long as they're different, you get a high. Doesn't matter which one's which. As long as they're different, you get a high. So that's going to give me a 1 coming out. And let's say that's where I'm starting with. I now have a 1. So if we move the filament just a little bit until it switches over, then this will go low. And so that will give me a low here. That'll immediately change this to a low. And so right now they're the same. And it doesn't matter if they're both low or if they're both high, that's going to give me a low. So right now, the moment that changed, those are both low. So that's going to give me a low coming out. But if we follow this path, well, that's now a low that changes to a high, changes to a low, changes to a high. So now that goes to a high. Well, then that's going to take that to a high. But it happened pretty quickly. So what happens is this output here is high, but as soon as that rotary encoder senses a change, I get a pulse low, and it goes back to high again. And as soon as it changes, I get a pulse low, and it goes back to high again. And it doesn't matter if it changes high or low. It doesn't matter. Every time it changes, I get a pulse low. And what that's going to do is it's going to reset a timer. So I have a 555 timer that's just putting out a signal every couple of seconds. And then the actual timer that I'm using is this. It's an 8-bit parallel out serial shift register. And so what happens is, let's see, I believe A and B, if we take a look at the table here, if A and B are high, then that's going to start my outputs high, and it's just going to count. The clear reset goes high to reset it. Then we have the clock signal. So A and B are tied together to positive, and then we have all of the outs, QA, B, C, D, then E, F, G, H. We have power at pin 14. We have the ground at pin 7. We have the clock coming in at pin 8, and the reset coming in there at pin 9. The clock signal is coming from, sorry, get that back in view here. The clock signal is coming from a 555 timer, and then that clear reset is coming from the output of that exclusive OR gate. So let's just take a look at it in action. So we'll get the circuit board back out here again. Now, I will tell you, I'll be honest, I'm obviously not an electrical engineer, which means any way I figure out to do something, I guarantee you there's a better way to do it. Now, a lot of you might be thinking, why not just use some microprocessor, like an Arduino or basic stamp or something? And yeah, that would work. That's a good option. I've got nothing against those. But for me personally, when I can build something like this out of basic components, because there's only like 4 ICs. There's the inverter, there's the exclusive OR, there's the 555, that's the shift register. This one is just a bank of resistors. That's all that is. It's just a bank of resistors. There's like 16 resistors in there. I'm only using 8 for my light array here. To build a circuit like this on a Arduino, that's like, you're only using like 0.5% of what that Arduino is capable of. And for me personally, when I build something out of just basic components like this, I'm so much happier with it. I'm much more proud of my work. I'm much more proud of what I did rather than just writing code. Now, don't take that the wrong way. There's nothing wrong with writing code. Writing code is not easy. I've done a few projects like that. I just think that you should, if it's a really simple circuit and you could do it out of basic components, you should do it that way. If you got a really complicated circuit that needs to change or evolve over time, then sure, use a microprocessor. Plus, I only have a couple of microprocessors, and I have literally hundreds, maybe thousands of IC chips that when I get a chance to use them, I definitely use them. So I've been collecting ICs for, man, I don't know, my whole life, I guess. Anyways, so let me plug this in and demonstrate how it's going to work. So we'll plug in the power supply and turn it on. You'll notice right away all of those are lit. But as soon as I start moving the filament, it resets, and you can see it's counting now. And it's about every 3 or 4 seconds, 2 or 3 seconds, it'll go up. And right now, so I'm not moving the filament. So right now it's counting how long the filament is not moving. And the idea is once it gets to that red one, then it would trigger a remote alarm, and then I would know about it right away. And if I just move that a little bit, so first notice these 2 LEDs right there. As I move this, those are just flashing back and forth. So that's just so you could see what's happening with the filament monitor here. We don't need those in the circuit for it to work. I just put that there so you could see what's happening as I move that. So again, I stopped moving, so it's counting now. And it doesn't matter if it stops on a high or a low. So if I just move it till that red LED changes to the other one, notice it reset. And now it's counting again. And if I just move it again, and notice it reset. Now if we watch how long it, or how much filament moves before it resets, about that much. About that much. I don't know, what is that, 7 millimeters? So it's not a lot. So again, the reason why I think this is almost better is because when the printer is running, I mean, sometimes it's going to be pulling that through pretty quick, other times it slows down, sometimes it just kind of pauses, or sometimes, you know, my printer on occasion, every once in a while, just kind of sits there for 5 or 6 seconds. It doesn't do anything. I don't know if it's thinking, or if it's just taking a break, or what the problem is. I'm not sure exactly what it's doing there. So as soon as it stops, I want to give it plenty of time. I don't want to get a false alarm. And by the way, this potentiometer here, I already experimented. If I replace that resistor there with that potentiometer, I can adjust this to go all the way from 5 seconds from here to here, all the way up to 18 seconds from here to here. So that'll be part of my project, and so I can fine tune it to get anywhere from 5 to 18 seconds of counting time here. And again, hopefully this makes sense why I'm doing this. I don't want it to just pause the machine, and I don't want false alarms. I want to know about it as soon as it stops. Now I have not got the little pager thing yet. It's just a 1-channel HF receiver transmitter unit. I have not got that yet. I'll probably get that in the mail probably next Tuesday, or this coming Tuesday or Wednesday maybe. And then the final output, that red LED, will trigger that remote, and then I'll just carry a little thing on me, like a little pager thing, which will let me know what the problem is. Now, eventually, what I might do is go ahead and figure out how to make it pause the machine. I know that's possible. I just haven't figured that out yet. So it will alert me and pause the machine. But as long as I resolve the issue, within a couple of minutes, the part will be saved. I have actually walked into the garage and checked on a print and noticed that it wasn't extruding, and noticed that it had missed a layer, and I was actually able to refeed the filament and get it going again and save the print. So again, as long as I save it before it skips 2 or 3 layers, then it'll be fine. All right, so I've got it temporarily mounted there. I don't think I like it there, but it works, it's fine. And just printing a small little part there. And well, this box was my first attempt, and that just did not work very well at all. So that'll go away. But here's the board. So you can see, even though it's printing, you know, sometimes those lights change faster than others. You know, the filament is moving, but it's a small part, so it's moving slow enough that it takes a while for it to change. And I'm kind of thinking that if I were to just connect it to the ramps board of the printer, then I might get some false pauses, maybe. I'm not really sure how that how the firmware for that works. I know you change the configuration H. I don't know if you can set how long it waits for the signal to come along. I don't really know. I need to do more research. If any of you know of a good source online to kind of show how to do that, please let me know in the comments. Because ultimately I would like it to pause the printer like it's supposed to. But I want to make sure that it's good and failed and not just thinking it's failed. So it's looking like it's only getting up to, let's see, there's the third one, fourth light. All right, so it gets up to the fourth light. Yeah, so I don't think I've seen it get past that fourth light yet. So I could probably speed it up, or speed up the clock a little bit and let it get a little closer, maybe get to the first yellow or something. Yeah, so anyways, like I said, next step is to connect the red light to a relay or something, maybe just a transistor, to trigger my one-channel transmitter. Okay, so I got my little single-channel clicker remote from eBay, and pretty cheap. It's like $7, maybe 8, I forget exactly. But just a single on-off clicker. Obviously, I already took the guts out of there. The receiver comes in a box like that. This is way too small to hold the battery. Of course, you could run the wires out of there if you wanted to. But I took it out of there to put it in a different box. This circuit board is basically just a receiver, a little coiled antenna, and a relay. And on the circuit board, there's a little jumper piece that goes across a couple of pins, and that kind of sets the mode. The way it is, the way it comes, you click that once and it would energize and stay on. You click it again and it would turn off. If you take the jumper off, then when you click and hold it, it stays energized. Then when you release it, it relaxes, and that's what I wanted for my printer. So let's go take a look at that on the board and see how it's working. So again, I have the sensor right there, and that's just coming from, you can see the filament. The actual spool is there. I'm wrapping it around an empty filament and straight down. That way the cable kind of stays straight. And it seems to be working okay. Now this right here, this little box right there, that is one of those little clip-on ferrite beads. It's just a little plastic case that you spread it open, clip it around a cable and click it on. I don't know if that's doing any good or not. But I noticed on some much smaller parts I was printing yesterday, it kept failing. Like after 30 minutes, it would stop extruding. And I mean, just small parts like this one, you know, it was doing that. And so that's a scrap piece, obviously. And I couldn't figure out exactly why it was doing that. And then I realized, well, it started doing that more after I put that sensor on. So I just put one of those little clip-on, better view of it maybe, one of those little clip-on ferrite beads, and so far it's been printing that big piece for, can we read that, 3 hours. We're 21% done at 3 hours, and it's been printing flawlessly. So I don't know if that helped or not, or if it was just a coincidence, but I'm going to leave it on there for now because it seems like it helped. So again, the signals coming from the monitor are going into this printed circuit board right there, and every time it senses that the filament's not moving, it starts counting. Now that filament, again, I think I explained this before, it has to move 3 millimeters before it senses the movement. So depending on how fast or slow the printer is running, you know, it might take a while for it to move 3 millimeters. And so if the filament ever stops, if the extruder jams, then that starts counting up. So every time that turns off, that means that it has detected movement. And so if the filament fails, or if the extruder fails, then eventually that will count all the way up to the red light. That red light is triggered from that chip here, which is just a shift register. So as soon as we get the signal from there to the red light, that signal also goes to a transistor to a relay. The relay then connects the points. This is the transmitter here. And basically I just found that the center, that little push button, made the, notice how this has 3 contacts. So I think that receiver works for a 3-channel thing. It just depends on the case that it's put in. Obviously my case only had 1 push button. That went to the center button. So I just connect those 2 together through that relay as soon as that red light comes on. And when that happens, it triggers the receiver, which I put in this box right here. So inside that box I have the receiver, a 9-volt battery. It's a really simple circuit. The on-off switch just connects the battery to the receiver or disconnects it from the receiver. When that red light comes on, transmitter sends a signal to here, turns on the red LED, and it activates, I have a little pager vibrator motor inside of there as well. I can simulate that simply by disconnecting this pin, and that's what happens. So it alerts me. Come on, get that pin back in there. There we go. So as soon as that filament stops for 15 seconds or so, it alerts me, and then I know to come down and refeed the filament and get it going again. And the range of that is pretty good. It works clear across the other side of the house. And hopefully that should save a whole bunch of prints. And eventually I would like it to also pause the printer. I just have to do more research to figure out how to put a signal into that controller to pause the printer. I'm not exactly sure how to do that yet, but I'm sure I can figure it out. If you think this is a completely stupid way of doing it, you can let me know if you want, but you know, I'm going to keep doing it. For me, it works. And I'll play around with it more, and I'll eventually get it to pause the printer. But so far, this has saved several prints. I've been, that's probably the 4th or 5th part I printed with this setup. And so far, it has saved a couple of those prints where it alerted me, I came down, I refed the filament, and everything was perfectly fine again. So eventually, I will put all of this on a printed circuit board and in a nice little box similar to that, and I'll have it mounted right there on the printer. And so, you know, that whole setup here is just kind of temporary. It's just for testing purposes, just to make sure that it works the way I want it to. And so far, I think it is. So the next step, I'm going to put all that on the circuit board and in a box. It's a really simple circuit. Again, there's only a few ICs and a couple of extra components. And I'm just going to use, I ordered a whole pack of these right here. I got like 20 of those things on eBay. They were pretty cheap, double-sided. So normally when I do a circuit board, I like to, you know, I like to etch the lines and drill it and all that kind of stuff. But for something like this, I mean, that's simple enough. I'll just put all the components on the board like that and just do point-to-point soldering, and that'll be perfectly fine. And put it in a box and it'll be done. You guys don't need to see me do that. And I'm going to actually call this video done. I think I've rambled on about this thing way too long. You guys are probably getting tired of it. But anyways, that is how I am using the Bigtreetech Smart Filament Sensor. If it gives you an idea, you know, if you like the idea, feel free and, you know, do it yourself. Pretty simple. And so anyways, I'm going to stop rambling. So until next time, as always, thanks for watching.